Building an AI agent prototype is easy. You can spin one up on your laptop in minutes. But actually trusting that agent in a live enterprise production environment, well, that is a massive systems engineering challenge. In today's explainer, we're moving way past those fragile, clever demos. Instead, we're going to look strictly at the architectural blueprints required to build resilient, secure, enterprise-grade AI agents. Here's the structural blueprint we'll follow to bridge that prototype to production gap. We're going to start with core agentic design patterns, then move into building production guardrails, examine the automated agent ops lifecycle, discuss real-time production operations, and finally, we'll lock it all down by mitigating enterprise security risks.
Let's kick things off with Section 1, Core Agentic Design Patterns.
Let's dive right into memory architecture. Look, large language models are inherently stateless. If you're going to scale your agents horizontally, say across a serverless platform like Cloud Run, persisting memory externally is absolutely non-negotiable. Notice the necessary split in state management we have here. On one side, we've got short-term buffer memory. It's extremely fast and strictly session isolated for the active conversational context. On the other side, long-term vector DB storage acts as your durable, scalable state. Without externalizing the state, the second your container spins down, your agent develops instant amnesia, and we definitely don't want that. So how does an agent actually execute a complex task? Static software follows predefined logic paths, right? But agents don't. They assemble their execution trajectory dynamically. Step 1 is reflection. This means programming the agent to self-evaluate its initial outputs before ever presenting them. Step 2 is planning. This is taking a complex, ambiguous user request and structurally breaking it down into manageable subtasks. And step 3 is react. Reasoning and acting. The agent reasons about which tool to use, executes it, and then observes the result. And if a tool fails, the agent actually uses that reflection loop to autonomously self-correct. It's brilliant. Now, speaking of tools failing, let's look at integration mechanics. When you bind APIs to an agent, those APIs will eventually fail, time out, or just return garbage data. You simply cannot let your agent spin into an infinite reasoning loop when that happens. Notice the allowed paths scoped strictly to a temporary directory. But crucially, look at the exception handling. If the API errors out, we force a deterministic fallback. Essentially, we physically pull the agent back onto a known, safe execution path. Moving right along to Section 2, building production guardrails. An agent doesn't just magically prevent itself from giving away free products or accessing confidential databases. That safety has to be engineered through a really critical collaborative handover. On one side, you have prompt engineers acting as the constitutional framers. They define the expected behavior, craft the strict system instructions, and most importantly, they curate the golden data sets. These are the exact test cases that define acceptable and unacceptable outputs. On the other side, AI engineers are the builders. They take that constitution and they scale it. They build robust backend systems, safely integrate external tools, and enforce those guardrails right in the infrastructure. This brings us to arguably the absolute most important concept in enterprise AI deployment, evaluation as a quality gate. You see, traditional software unit tests, they're practically useless for systems that adapt on the fly. An agent can pass 100 unit tests for its tools, but still fail spectacularly by hallucinating a response or choosing the entirely wrong sequence of actions. That is exactly why we must evaluate its behavioral trajectory. We assess the entire reasoning path it took to arrive at an answer, and we compare it against those golden datasets we just talked about. If the logic is flawed, the agent simply doesn't deploy. That perfectly sets up Section 3, the automated agent ops lifecycle. So how do we actually enforce that quality gate at scale? Well, we build the factory floor using a rigorous continuous integration and continuous deployment pipeline. Step 1 is pre-merge integration. This is where we shift left our testing. When an engineer updates a prompt or a tool schema, it instantly triggers our automated evaluation suite. If the agent's performance degrades even slightly, the merge is blocked. Step 2 is post-merge validation. The code gets packaged and deployed to a staging environment for heavy load testing and systems integration. Finally, Step 3 is gated deployment to production, which, and this is key, always requires manual human-in-the-loop approval. Notice how code, prompts, and configuration files are all treated as a single composite system here. Because an agent is so incredibly dynamic, a minor tweak to a system prompt can completely break how a tool is utilized downstream. By forcing every single artifact through this progressive funnel, we're trading manual uncertainty for automated confidence. Every component is strictly versioned. This means if a hallucination somehow slips through, you have an immediate, version-controlled undo button to roll back to the last known good state. Let's transition over to Section 4, Real-Time Production Operations. All right, here is the hard truth of enterprise AI, 80%. As fun as building the intelligence is, we consistently observe that 80% of the effort in agent development is actually spent on infrastructure, validation, and real-time operations. The clever demo is the easy part, folks. Babysitting it in production is the true systems engineering challenge. To manage unpredictable compute costs and latency, you need a continuous operational loop. First up, observe. You absolutely need logs for factual actions and distributed traces to follow the agent's dynamic reasoning path. Second, act. Workloads fluctuate wildly in this space, so you must design for horizontal scaling and offload long-running tool executions to asynchronous queues, just so the agent doesn't bottleneck. Third, and honestly most importantly, evolve. When an agent fails in production, and trust me, it will, you extract that exact trace, add it to your golden dataset, and ensure your automated pipeline tests against that specific failure forever. And finally, Section 5, Mitigating Enterprise Security Risks. Autonomous agents make decisions, which creates some very distinct security nightmares. First on the list is memory poisoning. If a malicious actor slowly feeds false information into your agent's long-term vector storage, they can literally brainwash the agent's future behavior. Second is tool misuse. This is tricking an agent via prompt injection to execute a tool it shouldn't, like, say, sending out a massive spam email campaign. Third is privilege escalation. If an agent inherits the permissions of the developer who deployed it, rather than a strictly scoped service account, you've essentially just given the intern the CEO's password. No way we can let that happen. To mitigate these threat vectors, we must implement a strict zero-trust architecture. Zero trust assumes everything is potentially compromised. You have to enforce input validation before the prompt even hits the model, strict authentication on the APIs, and continuous monitoring. The absolute critical takeaway here is that you must verify every single request. Yes, even the requests generated autonomously by your very own internal agents. Let's look at how this is enforced right at the code level. Here, we're binding a tool to the agent. We absolutely do not give it a delete all files command. Instead, we give it delete temp files only, implementing role-based access control by hard-coding specific allowed paths. And for anything destructive or high stakes, we set require confirmation to true. This physically forces the agent to freeze its reasoning trajectory and ping a human in the loop for authorization. That right there is least privilege access in action. Which leaves us with the definitive question for your architecture. Are you building fragile prototypes, or are you building production-ready agents? The technology is already here, but the operational discipline of agent ops, rigorous evaluation, automated deployment, zero-trust security, and scalable memory, that is exactly what separates a clever toy from a trusted digital employee. I highly urge you to leave the prototyping mindset behind. Take these blueprints and go build systems your enterprise can actually depend on.